you. So, good morning, everyone. I hope everyone is having a great, meetup and learning from peers. So, most of us are probably familiar with the typical physical factory setup and hence understand, some of the difficult conditions under which the factory workers operate, right? How, that can impact the production lines, the time to market, worker safety, and so on, right? So in today's session, we'll quickly review some of the ways how AWS can help you turn your factory into a smarter one and address some of these challenges, right? So to talk about that, I'm Yogish Kutkunje, a senior solutions architect at AWS, helping some of our large global manufacturing customers build similar solutions. So, in a nutshell, this is what we are going to cover. We'll talk about what and why of smart factory, and why is it actually important for manufacturers? What is the outcome they get, and how AWS can help you in setting up a smart factory. Right. We'll also quickly review some of the success stories from our customers, and then give you a quick rundown of some of the reference architectures. Right. So we'll start with what and why piece first. So, when we talk about smart factories, the first thing probably comes into mind is the industrial IoT, right? Definitely Internet of Things. So you have devices, large equipments, which are part of the assembly line or the production line, which have got a lot of sensors that can monitor and capture different aspect of the machine's health, right? Be it temperature, be it vibrations, and so on. So it's not enough that we just collect this data because we're not going to get any good out of it, right? We need to drive insights out of this data to make some of the meaningful outcomes for our manufacturers. Now, with the key objective which manufacturers keep in mind, to get out of this data is essentially to increase the revenue and decrease the cost down, right? Now, to get there, some of the key aspects which they would want to address or keep in mind is basically how are their workers operating, right? That's the first point. Second thing is in terms of security of both their physical assets as well as digital assets. So are those secure when they're deployed in the factory and on the cloud, right? Third would be, and probably one of the most prominent one maybe, is the overall equipment effectiveness, right? So OEE, this is a key metric for every manufacturer because it tells them if they are profitable in a way or not, right? Are there enough returns on investments that they put into these large factories? Fourth aspect would be supply chain, because of course, you need all the raw material supply that is required for manufacturing. And this is very relevant for everybody who is distributed, right? Be it from our Indian conglomerates to the global conglomerates. For everyone, optimizing supply chain is very important because the cost of inventory is so high that, you cannot be overstocked. At the same time, you cannot be understocked as well, right? And that's where we will see how we can apply technology. The next area would be data, right? As we spoke, how important is data? These factories are typically siloed in nature, which means that they do not have network connectivity either between them, right? If a big conglomerate is operating hundreds of factories, then having a connectivity between each of these factories probably becomes difficult, or probably there will be poor connectivity between these factories. Hence, the data silos can happen. And also, let's say, even if you have connectivity, how do you ship all the data back to a single point or into the cloud and make sure that you drive insights out of this data, valuable data, in time, right? So that's another key challenge there. And let's say if you have now by some way have achieved the optimization of your supply chain, your manufacturing process, that's where you get time for introducing your new products, right? Your time to market gets accelerated, and that's when you get thoughts of going into NPI part of it, right? New product innovations. So, just to give you a brief background of what a typical manufacturing setup looks like, I'm sure most of you are familiar with this. On the left hand side, we are talking about some of the common processes within a typical manufacturing setup. We talk about job shop manufacturing, which is basically a made to order scenario, right? So it could be a small, auto part or a machine part that has been ordered for manufacturing, or it could be as large as a HVAC, chiller or a, air conditioner that is sitting right on the top of the building, right? But keep in mind that when you say job shop manufacturing, it's only one piece that is ordered by somebody and made it custom for their order. The second thing is the repetitive manufacturing, which is very common form of manufacturing that we see. You have large production lines that keep out churning product after product, part after part, right? So that's basically your typical repetitive manufacturing process. The third one is discrete manufacturing process. Again, here the assembly line is capable of, or the product line is capable of churning out multiple products out of the same production line, right? So that's like, it can do diverse set of manufacturing in the single line, with a few adjustments to the production line, of course, right? And similarly, on the right hand side, you have setups of the production lines itself. So if you talk about a production line, is basically nothing but a large chain of continuous production that keeps happening on this particular line, right? And then the second aspect is about assembly line, where you have different parts of the of single product coming in into a single line, and then these get assembled and thus arrive at a finished goods, right? Then the third one is probably, in some scenarios, rather than moving the parts nearer to the operator, it becomes easier to move the operator nearer to the part, right? So that's where the manufacturing cell concept comes into picture. And this often, in those scenarios, results in improving the production at a faster rate, reducing the wastage, and also the time to market also increases in this and again, very very scenario driven setups, right? It's not like one size fits all kind of scenario. Yeah. As I spoke earlier about OEE, the overall equipment effectiveness, right? This is one of the very key metrics which most of the manufacturers measure. It is dependent on three aspects here, right? One is availability. So when we talk about availability, it's like the uptime of your production line, right? So within a production line, you essentially have a planned downtime and then you have an unplanned downtime. Yeah. So planned downtime is basically recommended by your machine manufacturers, who would have given that machine and said that every 18 months you have to take a downtime and essentially do the maintenance of this machine. If they are large machines, or if they're smaller machines, you have every 6 months, once a quarter kind of a cycle, right? So that's how the planned downtime works. But then there is unplanned downtime, where because of these various factors like the temperature, the aberrations, the vibrations that the machine is going through, it can yield into a faster downtime or a breakdown of any of the parts, right? So now, how do you address that? How do you minimize that, right? So that's where the availability comes into picture, and how technology can help you in predicting these beforehand, to so that you do not have to handle these unplanned downtime a multiple number of time, right? Second area is essentially the quality. This is basically a percentage of your total production that is meeting your good standard, right? So where actually how you can measure is basically, you have your manual quality control processes, which basically gets augmented with your production line, where every product that is manufactured out of the production line is monitored and made sure that it is meeting your good standards, right? And the acceptance and the rejectance happens on the basis of that monitoring there. But it is all manual in most of the industries even today, right? Then the third one is the performance, right? So essentially, out of the total products that you have churned out, how many have been, what is your performance? What is the total, the ideal cycle time for each product, and the total count of the products that you have produced, right? So that's what gives you your performance of the production line. Yeah, these three measures we have to keep in mind. Now, let's now quickly jump into the smart part of the factory system, right? So again, to give you a brief of, IT and OT, right? So when we talk about a manufacturing setup, you have the information technology, and then you have the operations technology. Operations technology is basically where, your shop floor runs, right? So all the production lines, the manufacturing execution systems, the edge systems, those are all part of your operational technology. And we are probably, from the IT side, we are all aware of the left hand side, right? So you have your ERPs, you have your CRMs, you have your dashboards, you have your business process supported applications, and so on. So those are all sitting in IT. And in between there is a IT OT overlap area. That's where you have your product lifecycle management PLMs, you have your historian, which will give you a planning capability for your the production lines, and you have your manufacturing execution systems, like I said, that can help you. And then of course you have your analytics application pretty much everywhere, right? Because analytics is one piece that is needed for every process to understand the efficiency of that process. Yeah. And also on the OT side, you have something called as a supervisory control and data acquisition system, which is basically SCADA, right? Very very commonly used in every operation and technology, out there for every industry, right? So that's where the machine supervisors get their insights and are able to take action, right? So these are some of the terminologies that you would need to know, and this is how a typical workflow looks like. And based on some of the standard frameworks which have been deliberated several number of times, Purdue University in the US came up with this ISA 95 model, which typically has been represented as a pyramidic structure, or in a these level kind of a structure, right? So essentially the message here is to give you insight of all 6 levels that are involved in making a factory into a smart factory ecosystem. Yeah. The level one, if I start with, probably that's very similar to our OSI network model as well, right? So it's the physical layer where you have devices like sensors, cameras, and actuators and so on. These can actually capture some of these data points, and probably they do not have any high level of intelligence built into them, right? The best probably they can do is cut off, right? So, based on temperature there can be a cut off, and they can turn off the switch. Maybe that's the best they can do. Too much of vibrations, you specify a threshold, the machine gets shut down, right? So that is the level of control you're looking in the layer one. That's where the physical process layer comes into picture. Then as we move on to the layer two, they have a bit of more intelligence, which is where the PLCs come into picture, right? They are more like programmable logic controllers, and that's where they can actually talk to some of the gateways, right? Like IoT gateways and so on, and hence are able to do more than just turn off, right? So they can actually, you can have a workflow, small workflows built into this, programmed into these PLCs, and on the basis of that they can take action. HMIs, human machine interface, also fall into this range. They can also do similar function by interfacing with something called as SCADA, which is in the level 3 plus 4, right? SCADA is basically supervisory control and data acquisition, as I mentioned. So whatever the data that comes out of your level 1 and 2, that can get processed in SCADA, and it gives you insights, and again an interface with HMI, so that based on the decision that you take on the insight from SCADA, you can instruct the machine to perform in a certain way by using HMIs. Yeah. Then as you move upward, then you have your manufacturing execution system, MES. That's where most of the automation around production control happens, right? So basically you get all of your production schedules, plans from your ERPs, and once this information is there in MES, you start pushing them into different systems that are part of your MES, and the production kicks off, and there's a supervisory mode where they can observe what is the performance, what is the quality, and things like that. Yeah. But imagine the pain if MES goes down, right, for a day or week. That's actually a big no-no, right? Essentially, there is no output coming out of the line, and then the OE is going for a toss, right? So that's how important and crucial MES is. And the last level, as you see in the level 6, that's basically your IT layer, and that's where your ERPs, CRMs, and your production schedules, logistic systems, supply chain systems, all of these are sitting, right? Essentially more of planning and control, sort of IT background systems. Those are lying there. Now once we have an idea of this, let's look at some of deeper concepts where AWS can help you to, align with each of these areas, right? So one of the common observation that we have, collected by talking to multiple of our customers whom we have helped in IT/OT area, essentially, when it comes to OT, the sheer amount of different kind of protocols that are involved, right? Because as I think Nitish was mentioning earlier, G itself is an example. We talk about 130 years of legacy. So imagine the computerization of that entire 130 years of industry, supply chain, ERPs over a period of time, right? So there are so many technologies coexisting within GE, and similar customers like GE, right, who have conglomerates and distributed operations in multiple countries. So when it comes to different type of devices in your operational technology, essentially within your factory, this is the distribution which we have seen from some of the studies, right? So while Modbus is one of the common, which is still commonly prevalent, and OPC UA is another one which is commonly prevalent. If you look at the largest chunk here, which is scarily none, right? So there are a lot of such protocols which we do not even know. There's no documentation, and there's no way to go back and modernize that without taking down the entire device or remodernizing the hardware of the device itself, right? So that's the highest bucket there. Just wanted to give a sneak peek of that data. Now, how do you start applying AWS for smart pack factories, right? So we'll again start from from your OT all the way towards IT, right? So if you start with OT, the first thing that comes into mind is, again, we talked about these devices which run on different kind of protocols, where you might have your own proprietary protocols, right? So I know that some customers do run their own custom protocols, proprietary protocols, which is an edge and advantage for them, right? So that's where they need freedom in terms of having an OS which gives them the security aspects of it, angle of it, the cost advantage of the cloud, and the agility part of the cloud. But at the same time, it also gives them the freedom to run their custom protocols and their custom applications, right? So that's where we start with something called as free RTOS. That's AWS's offering of open source real-time operating system, right? Then as you move on, let's say you want more than operating system, and you want capabilities of a managed device that can give you a device plus an operating system at the edge. That's where IoT Greengrass comes into picture. Now it is not just a sheer device, right? So you can actually build machine learning models which are be it for computer vision, or be it for anomaly detection and things like that, which are very custom for your data set. You can train them, you can deploy the endpoint on the edge, and now you can run inference within your factory, right? So that's where IoT Greengrass has the edge. And as you move towards the right, you have something called as the sitewise. Again, sitewise, you can compare this to SCADA that I talked earlier, right? It's like a supervisory control and data acquisition kind of a mechanism, where it collects the data from edge devices. And again, this is also residing within your OT environment. And at the same time, as it collects the data in real time, it has the capability to give you local analytics on IoT and plus dashboarding, right? Which means that the insights for supervisors is available in real time at the edge. Then as you move further, right, this is where the OT converges with the IT. So I'm sure some of you are already familiar with our Snowball service. So this can be adopted for your local storage and local compute requirements within the edge, right, within the OT, within the factory itself. So this is very suitable for, again, low latency requirements, where you might have some use cases that have to happen locally without even going to cloud, right? After the processing, they can have a asynchronous data sync with the cloud, but for the real time requirements, they can you can leverage edge, Snowball edge there. And then as you move further to the right, you have capabilities in terms of outposts and wavelength, very suitable for a little bit of farther distance. Maybe you are okay to take that processing to maybe nearest data center that is available. And because for the fact that in some of the countries we do not have our regions, and that's where data locality or the regulatory requirements dictates that it has to happen within their country. I know for sure that there's some ASEAN based countries where this is a very classic use case where it would fit, right? So outposts will come into picture there. Similarly, connectivity is another area where we saw that customers face frequent problems within the factory area, right? So that's where AWS Wavelength can come in, where you can work with our telco partners, and you can have a dedicated 5G private network established within your factory now. Giving you capability to have a backbone connectivity again with AWS, and at the same time have a very solid connectivity within the factory area as well, right? So that's how you can convert your network piece of it within the factory into a smarter zone, right? And then on the right hand side, you're all very familiar. That's where you can do all of your asynchronous processing for your back office and IT applications. So again, going back to those three areas, just to quickly map out what we discussed, right? So when it comes to quality control, we will look at a couple of services in the subsequent slide, but this is where edge processing in terms of computer vision would come in to detect your quality of the product and make sure that the acceptance and the rejection happens in real time, not with the human intervention, right? Everything happens automatically through either your custom models or proprietary machine learning models, vision models, or you can leverage AWS's service called as Panorama and our models deployed on Panorama, which can help you in computer vision use case. When it comes to maintenance and engineering use case, you can have your you know uh, again the predictive analytics around planned and unplanned downtime, uh, right? Determining the anomalous behavior of your machine's data by running some of the edge machine learning models. So that's where your green grass kind of a solution could fit in. And the last one is warehouse and supply chain optimization, right? So again, here we have services like AWS supply chain, which can connect with your multiple ERP systems, which are existing ERP systems, and it can give you insights on your inventory rebalancing, your warehouse situation in terms of whether it is filled rightly or whether it is depleted, the inventory is depleted, and so on, right? So all of these insights can come in through AWS supply chain. And with recent reinvent concluded, we have also announced there is a support for Amazon Q that is coming into AWS supply chain as well. Yeah. So now we'll start quickly talking about a couple of customer success stories here. So the first one is around Volkswagen Group, where their main challenge was to enhance the efficiency across different manufacturing plants, ensuring that connecting their plant machines and legacy application, right? So the focus was to implement a solution like digital shop floor management, so that they can have a standardized platform for enterprise wide improvements, right? So that's where AWS team collaborated with Volkswagen. So this is the same classic problem that I was talking about a few slides earlier, right? So you have challenges because your plants are spread across in and the data is in silos, right? What Volkswagen used was they started using some of our IoT services and platform services, and leveraged AI/ML models also to be deployed on the edge, and thus made that ecosystem as smart, right? And ensured that they had real-time insights. And rather than going as a per use case basis, they went on to deploy it as a big bang approach, and that actually gave them reduction of essentially improvement of their efficiency and productivity by 30%, right? So that is the improvement that Volkswagen was able to achieve. um, Another of my customer, which is Carrier, which I support, essentially I've contributed to some of these architectural patterns as well, like where one of their BUs called as the refrigeration BU, they had their cold chain, which is totally fragmented currently, right? So because there are so many vendors involved, and because of the diversity in vendors, you have different technologies that are involved. And because of that, what was happening was there was lack of visibility into the location, the condition, and handling of goods in transit, which was basically posing a risk of temperature fluctuations, yielding into equipment malfunctions, and the product going stale, right? So that's where Carrier put together the whole Links platform, which utilizes our AWS IoT services to gather, integrate, and organize, and plus analyze all of these data in real time to get the real time insights of the equipment data. And then on the basis of that, they were able to take necessary actions in time, right, proactively. This also helped them in decreasing overall energy use, and optimizing their entire the cold chain infrastructure as well. Now, quickly showing you some of these services in action, right? So as I mentioned, I'm not going to talk about the cloud piece of it because most of us are familiar. If you look at the OT, or the factory infrastructure, so this is where we were talking about multiple, protocols, right? So you have MQTT, you have OPC UA, Modbus, OPC UA, different type of protocols that are coming in from your existing equipments. And because this all of data is processable through IoT Greengrass, we have this gives you a good way to deploy any sort of small applications or ML models on the edge, right? So, and also all of these different data that are coming in different protocols that can also be translated into one single MQTT based protocol through site-wise connector. And then site-wise connector will talk to send the data to IoT core. From there, you basically have the access to do whatever the analytics that you have to do. When we spoke about two other systems, MES and Historian, you can have storage gateway, like a solution which is deployed again on the edge to sync the data in real time to your cloud, right? So I mean, if you have some leeway to process that data, you can afford asynchronous mode, then there's option between data sync and storage gateway that you can choose, and get the data back to cloud, right? So this is one pattern when it comes to modernizing your the factory ecosystem. Another interesting use case is the quality assurance. As I was telling earlier, one of our largest food processing conglomerates in the US, Tyson Foods, they leverage computer vision models which are deployed on the device called as Panorama. So AWS Panorama is a service which gives you the both the hardware and software capabilities, where you can have the device kept on on the edge along with the camera, and this camera will send the real-time feed into the device, where the computer vision model will be able to parse these video feeds and make sure that what is the right you can establish the standards for your quality specifically, and on the basis of that it can accept or reject the product, right? So that's the use case. So this is where you can see the Panorama in action. I'm just going to talk about a couple of more services like Monitron, which is again which comes as another service which comes with three different components to detect mainly the vibration piece of it, right? So that's another data point which can give you insight. Based on that data, you can do a predictive maintenance predictions and things like that. So that's one of the services. And then lookout for equipment is again on the quality use case. This will come into picture if you have a little bit of room between your production cycle and the quality cycle, right? So you have produced the products, and while you're at it, you have recorded the videos, and you have some breathing room where you can ship this videos to the cloud, and lookout for equipment can do the detection of quality offline for you, right? But if you need it in real time, then Panorama is what you're looking at, right? So these are a couple of the capabilities that I wanted to highlight. And another aspects, I think we have spoken about this earlier. When it comes to running machine learning on the edge, so there are quite a bit of few capabilities that you can have, right? You can have a protocol conversion, you can have data transformation done at edge, you can have data synchronization done in real time, to the cloud, and also you can have run your machine learning models and apps at the edge, right? So this is more from edge capability standpoint. And finally, to get a head start for you, AWS understands how fast it is. How important it is for customers to get ahead of the curve and deploy some of these solutions. We have created a curated solution library which talks about various, aspects of this smart manufacturing. Just to name a few, virtual Anton card is a very similar principle where you can optimize the entire production line and by detecting the issues beforehand, right? And similarly, you have connected factory architecture, which we saw earlier, that is also available as reusable assets. And we have a predictive maintenance solution also that can give you capability to collect and predict, collect data and predict the unplanned downtimes as well. So that brings me to end of presentation, and now I'm open for any questions you might have.
Hey, great. Thanks so much, Yogish. Team, feel free to ask questions there. We might not be able to take up all the questions because of the time constraint, but we'll definitely try to answer them on the chat or separately. Okay. And Yogish, so I just see one question there. What is the solution guidance in the asset maintenance and reliability?
Okay, so when it comes to asset maintenance and reliability, the couple of guidances that we have from AWS. One is called as machine to cloud connectivity framework. You can actually connect your on-premise operation technology assets to AWS cloud for data ingestion piece of it. Second one is virtual and-on, which I called out earlier, right? So you can provide basically and-on system provides us scalable framework for optimizing the process and also supporting the transition to predictive maintenance and so on.
Great. Okay. So next one is, do we have a telco tie-up with the AWS Wavelength in the ASEAN region?
So for India, we have a couple of telco tie-ups, and you can actually reach out to your account team. They'll be able to coordinate, if there is a support that is needed, right? So like the leading service providers within India, we have a tie-up with them. I may not be able to name them, but your account team can work with you through existing agreements.
All right. Next one is from Sanjeev saying, can we have a similar kind of architecture for EV car manufacturing factories?
Yeah, so very good question, Sanjeev. So see, when it comes to these architecture patterns, they are relevant for any manufacturing factory system, right? Be it from the smallest part to a largest of CHVAC kind of a manufacturing, right? So it's just that you have to identify what kind of existing setups you have. You have a production line or you have an assembly line, and then pick and choose which of these services would actually fit, right? You may not have to go big bang on the entire setup, but rather pick and choose some of the problem areas, high value problem areas, and go after them, right? So